Today we will draw flange coupling. Yeah. Now write the question. Draw a flange coupling bracketed protected or non-protected for 30 millimeter dia. Okay. Now first of all we will draw protected flange coupling. Yeah. And here this is for front view and side view. Okay. So take your exercise book flat condition. Yeah. And for, look at the board, for front view this is limited size. Okay. And for side view there are many circle here, so you take the bigger size here. Yeah. Now at the first step draw center line, and this is light line. Yeah, this is light line. Quick draw center line. Yeah. Now for shaft, remind it shaft dia. This is capital D, 30 millimeter. Yeah. So at the upper position this is 15 millimeter, and the lower position this is 15 millimeter. Yeah. So, and this is also light line at the first step. This is light line. Yeah. 15 millimeter. This is 15 millimeter. Yeah. And here there is some space for dimension. Yeah. And at the closing side this is manually draw. Yeah. Because at the left portion the shaft is extended, and there is some space, and here dimension, this is half dia, half or boss. Yeah, boss dia. This is 2D. Yeah, that means 2 into 30, that is 60 millimeter. Now here some from center line this is 15 millimeter, sorry, this is 30 millimeter, and this is 30 millimeter. That means this is 60 millimeter, as this is 2D. Yes, 2D, that means 2 into 30, that is 60 millimeter. Okay, that means from this to this is 30, and from this to this is 30. Yeah. Next, boss or half length. This is capital L, and this is 3D. Yeah. 3D. So here this is 3D. This is 3D. And that means 3D, 3 into 30, that means this is 90 millimeter. Yeah, this is 90 millimeter. Yeah, this is actually half. And for flange coupling there is two part. Yeah, one is socket and another is spigot. Yeah, to socket and spigot. So this is the assembly condition. Socket and spigot, this is assembly condition. Yeah. Now, so this is 90 millimeter. At the last portion, we will draw the dimension. Now, the closing side. Here, this is close portion. This is actually shaft. Yeah. And here, this is D, capital D. Yeah. Now at the mid portion there is a center line. there is a center line. Yeah. Now overall dia, remind it, overall dia. Yeah, this is 4D. That means 4 into 30, that is 120 millimeter. From the center position, this is 4D, but this is 2D and this is 2D. Yeah, this is 2D. Yeah. Next, yeah, this is overall dia. Now look at width of flange. Width of flange, this is 0.8D. Okay, clear your concept. Okay, width of the flange, this is 0.8D. Thickness of flange, this is 0.5D. And thickness of protected circumferential flange. Okay, thickness of protected circumferential flange, this is 0.25D. Yeah, all the dimension remind. Width of flange 0.8D, thickness of flange 0.5D, thickness of protected circumferential flange 0.25D. Yeah. Now, and this dimension here, width of the flange 0.8D. Here, this is 0.8D, and here this is 0.8D. This is 0.8D, this is 0.8D. Look, this is 0.8D. Yeah. And next, thickness of flange 0.5D. This is 0.5D. This is 0.5D. That means here this is 0.5D. 0.5D. This dimension. Yeah. Now, thickness of protected circumferential flange. Here, this is 0.25D. This is 0.25D. Here, this is 0.25D. Yeah. And this is deep line. This is deep line. Yeah. Now, at the next stage, this is 0.5D. That means thickness of the flange. And from this position, you shoot continuous thin vertical line here. Continuous thin vertical line. Thin vertical line, rewind it. This is thin vertical line. Yeah. Now, from this point, you shoot 3 degree. This is tapering. This is deep line here. This is deep line. This is deep line. Yeah. Remind it, this is deep line. That means here the portion, this is light line. This is light line. Okay. That means here from straight line, these degrees 1 to 3 degree. Okay. You can also draw here, this is a straight line. Yeah. Now from this position, this is deep line. This is deep line. This is the deep line. Yeah. Next dimension, remind pitch circle dia, PCD. Pitch circle dia, this is 3D. Okay. That means here from this to this 0.5D, from this to this is 1D, as this is 2D, and from this to this 3D, that means 1.5D. This is center line. Center line means 15:3:2:1, and this is light line. Yeah. Now all the dimension has been put here. Yeah. Next, bolt. Bolt, dimension of bolt here. dimension of bolt. Dimension of bolt. Okay, assume this is 16 millimeter. This is 16 millimeter. Yeah. Now, so this is 8 millimeter and this is 8 millimeter. Yeah. Bolt, we are right-handed person. So the nut at the right hand. Yeah. And here reminded this is 8 millimeter. So from this point to this is 8 millimeter. From this point to this is 8 millimeter. And here also from this point 8 millimeter extend. 8 millimeter extend. 8 millimeter extend. 8 millimeter extend. Yeah. Now this is light line. This is light line. Yeah. And from this position, from this point to this point, this is curve. Yeah. And this radius 0.25d and this 0.12d and this also 0.25d. Yeah. Now from this vertex, okay, you should draw deep vertical line, deep line, and look at this is a straight line, and from this point and from this point this is another curvature, and this is 0.15d whose radius. Yeah. And as this is protected, from this point you should draw deep line. You should draw deep line. Yeah. And this is the nut head. Yeah. And as the nut is turned through the bolt, so here there is thread. Okay. And we assume depth of thread. Depth of thread, this is 2 millimeter. Yeah. That means here from this point this is 2 millimeter and from this point this is 2 millimeter, and assume the thread here, this up to this position thread is extended. That means here the thread is end here, and this is the thread because the nut is turned over the thread. Yeah. And at the left portion of the bolt, this is bolt head. Yeah. And this is 16 millimeter, and here also this is from this point this is 8 millimeter, from this point this is 8 millimeter, and extend 8 millimeter, 8 millimeter, 8 millimeter, 8 millimeter. Okay. And now connect light line through this portion. Yeah. And just curve 0.25d, 0.12d, 0.25d. Okay. And from this portion you should draw vertical deep line as this is protected. Remind, if this portion touch this sheet metal plate, okay, then you can reduce. Remind it, if this portion touch this sheet metal plate, then this portion, this is 8 millimeter, you can reduce this portion. If this portion touch this portion or extended through this portion, okay, then you can reduce this 8 millimeter. Okay. So in this way you draw bolt. Now as this is the assembly portion and this is the left portion, yeah, and this is right portion, and now divide two portion. So this is section line, 2 to 3 millimeter gap. Yeah. Light line 45 degree angle, 2 to 3 millimeter gap, right angle, a 45 degree angle, and light line. Yeah, we assume the left hand portion this is socket and the right hand portion this is spigot. Yeah. Now next portion, the dimension of key. The dimension of key. We assume this is as the length of the half. This is 3D. Look at this is 3. That means 3 into 30 millimeter. That is 90 millimeter. So this is 45. So this is 45. So the dimension of key this is 45 is to into 8 into 6. That means this is length, this is width, this is thickness. This is actually this is this is 45 and this is 8 and this is 6 millimeter. And this key actually connect shaft and hub. Yeah. So and here in flange coupling there is two key at right angle position. That means here as this is assume this is shaft and this is hub, and we should this is shaft, this is hub, we should this is key, we should input through this position here. Okay, so at the front view you look, this is the length and thickness. Yes, this is the length and key. What you notice? This is the length and thickness. That means at the front view, this is 45 and 6. You should take the dimension. Yeah. Now, and here, this is thickness 6 millimeter. From point this to this is 3 millimeter. Yeah. Now, and now before putting dimension of key, you should draw recess. RECESS. Yeah. Now, this is the dimension of recess. First of all, dia of recess. This is 1.5D. Dia of recess. Yeah. This is the gap in socket. Okay, in which the spigot portion is extended. Okay. This is the dia of recess 1.5D. Next, depth. Depth, this is 5 millimeter. This is 5 millimeter. Yeah. And clearance. Clearance, this is 2 to 3 millimeter. This dimension is required here. Dia of recess, look. So from this is as this is 1.5D. So from this point, this is the hub 0.75D. So from this point, this is 0.75D. Yeah, this is 0.5 and this is also 0.25. Yeah, so this is 0.75D. And the depth, this is 5 millimeter, this is 5 millimeter. And so this is the cutout portion in the socket. This is the cutout portion in the socket. Yeah, and separate this position. Okay, and the clearance this is 2 to 3 millimeter. That means the spigot is input is extended here, but not touch this portion. That means here this is 2 to 3 millimeter. This gap, this is clearance. This is 2 to 3 millimeter. Yeah. Now separate this position. This is socket. This is spigot. Now draw the key. The thickness of the key. This is 6 millimeter. So this is 3 millimeter, and this is 3 millimeter, and this is deep dot because it is in the material. And at the upper right condition, this is 3 millimeter, but here this is 2 millimeter because the key here, this is a rectangular taper shank key. Remind it, the key is rectangular taper shank key. Okay. Shank key. As this is taper here, so this is 3 millimeter, this is 2 millimeter. So connect this portion. Connect this portion. This is 2 millimeter. Yeah. And as this is 2 millimeter, so extend this portion. This is 2 millimeter. And this is keyway here. This is the keyway. In this position, the key is to be hammered. Okay. And so this is as this is keyway, and this portion is cut from the shaft. So this is no material here. Yeah. So the corner portion is to be fillet. The corner portion is to be fillet, and so this is the deep line here, because as there is no material in the shaft. Yeah, and so this can be light line. Okay, and as there is two key, so the another dimension, look at, if this is the key here, this is another key at right angle position, so this is another key, and you should notice that this is the length and width. Yes, na? This is the length and width. As this is the length and thickness, so this is the length and width. So now take the dimension 45 into 8. Now 45 into 8, so this is the 4 millimeter, and this is deep line here, and as this portion, the keyway is the top view. Okay, so this is the center, and this is radius, and this is semicircle here. This is the keyway, and this is the keyway. Okay, this keyway in this position, and this keyway in this position. Okay, as this keyway in this position here, look at in this position, so you notice this is curve, but when this keyway in this position, you notice this is semicircle. Yeah, so this is the semicircle. Okay, now separate two portion. Yeah, this is thickness, a section line, 45-degree angle light line, and this is section line. Yeah, and you draw the flange coupling. This is 1/4 cut out. That means half section. Reminded, this is not full section. If it is full section, then the full portion has to be cut. And this is the half section. So this is 1/4 cut. This is the 1/4 cut. Must remind it. So there is no other drawing from the bottom, from the center line at the bottom condition. There is no necessary. The detailed dimension is to be put here. Yeah. So look at this portion, as this is 2D, as the overall dia this is 4D. So here also center line, this is here also, this is 4D, that means here 2D, and yeah, this is 0.8D, and from this condition, from this straight line, you should detail deep straight line here. From this condition, you should detail deep straight line. Yeah, and there is no necessary for drawing the details at the bottom condition. Yeah, this is piece circle dia. Yeah, and here the half, reminded, this is deep line, and here this is the deep dot line. Yeah, now the complete is front view. This is D, put the dimension. This is the half dia, this is 2D. Yeah, this is piece circle dia, this is 3D. Yeah, and overall dia, this is 4D. Yeah, and here the dimension, this is 8 millimeter. Reminded, here the dimension, this is 6 millimeter, and here this is the recess condition, and this is 0.75D. Yeah, it is completed for the front view. Yeah. At the first half, we have drawn front view of flange coupling. Today, we will draw side view of flange coupling. Yeah. Now, extend the center line. Concentrate. Extend the center line. Yeah. Leave some portion, and here this is vertical center line. This is vertical center line. Yeah. This is shaft. So this is projection line. This is projection line. That means this is 30 millimeter. Here at the first half, you will draw light circle of shaft. Light circle of shaft. Yeah. Now this is the key here. Yeah. And look at, this is the key, and when you look at the side view, you notice this is the width and thickness. Yeah. And you will draw this dimension. The width is 8 millimeter and this is thickness 6 millimeter. So here this is thickness 3 millimeter, and here this is 4 millimeter. Here this is 4 millimeter. That means this is 8 millimeter, and within shaft this is deep dot. And now this is 6 millimeter. So this is 6 millimeter. This is 6 millimeter, and at the outside portion this is deep lined. Yeah, this is deep line. And here, as this key is tapered, so this is another deep dot line here. This deep dot line is for this point. Yeah. Now we will draw this key, and this key isn't seen. So here the total is deep dot line. From this portion, this is 3 millimeter. This is 4 millimeter. Yeah, that means this is 8 millimeter, and this is 6 millimeter. This is 8 millimeter. This is 6 millimeter. Yeah, and beside this two key, and the total portion here, this is the deep line, and section line here. This is section line. This is light line, 2 to 3 millimeter gap, 45 degree angle. Yeah. Now we will draw the recess. This portion isn't seen. So here this is projection line, and here this is deep dot line. This is deep dot line. This is deep dot line. Yeah, this is recess. Now this is half portion, the half, and this is, yeah, deep line. This is deep line. This is the deep line. This is half. Remind it. This is shaft. This is recess. This is half. Now this is the circle dia. The projection line. This is this, and this is center line. Center line. This is center line. Yeah, and you can reduce time with irregular line here. Yeah, why this is? Look at from this point this is circle, from this point this is another circle, from this point this is another circle, and these three circle deep line. This is projection line. This is projection line. This is deep circle. Yeah, this is deep circle. This is deep circle. Here, look at here, the drawing is stopped, so this portion can be cancelled, so you can reduce some time. Yeah, and from this point this is another circle. This is another circle. This is also deep. This is deep circle. This is the deep circle, and here this point, this is projection line here, and this is another deep circle. So here this is 3 deep circled. Remind it, this is 3 deep circle. This is 3 deep circle. Yeah. Now we will draw bolt, side view of bolt head. Yeah, and look at, this is 16 millimeter and this is 32 millimeter. Look at, this is 16 millimeter here bolt dia, this is 32 millimeter total outside dia of the bolt, yeah, or nut head. And the thread dia, this is 2 millimeter gap, 2 millimeter gap, that means this is 4 millimeter from 16, that means this is 14 millimeter. This is thread, this is outside, this is bolt. Yeah, first of all we will draw 14 millimeter dia, and this is here, this is gap. Look at this is the first quadrant, and if we will draw in first angle projection, so at the first quadrant this is the something gap. Yeah, this is 14, and now this is 16 millimeter. This is light line. This is light line, and now this is 32 millimeter. This is the outside dia. This is outside dia. This is outside dia. Yeah. Okay. Now, if you draw hexagonal bolt, that means 6 side, and the side of each side, this is the dia 16 millimeter. So this is, first of all, this is 16 millimeter. The angle, this is 120 degree. This is also 16 millimeter. This is 120 degree. Yeah, this is 16 millimeter, and this is 120 degree. In this way, here also, this is 14 millimeter. This is 16 millimeter. This is 32 millimeter. This is 16, 120 degree, 16, 120 degree. In this way, here also, yeah, and this, yeah, and in this way, this is the side view of flange coupling. Okay, thank you.